Hello everyone. Today we'll move on to the next topic of your greedy technique, or the next method of your greedy technique, that is minimum cost spanning tree. Before going for this, first you must know what do you mean by spanning tree and what do you mean by the cost matrix or the cost graph, all those things. First, you must know what do you mean by a spanning tree. A spanning tree is a tree in which all the nodes are connected without forming a circuit. See, for example, I'll just take one graph. This is A, graph B, then I'll take C, D. This is A, B, C, D. This is a graph I have taken, and this, now I'll just tell you what do you mean by a spanning tree. What do you mean by a spanning tree? A spanning tree is a tree in which all nodes are connected without forming a circuit. Means, what is the meaning of that? All the nodes should be connected, but it should not form a cycle. If a cycle is there, then it will not be called as a spanning tree. With this one, how many spanning trees you can write? C. And one more thing you have to remember, all the vertices should be present. If you have to represent the spanning tree of this one, all the vertices which are present in the original graph should be present, but edges may be missing. See here, this is a one spanning tree I have written. See, all the vertices are there, the nodes, all the nodes are connected, but it is not forming any of the cycle. Okay, and in the same way, I can just write one more. See here, A, this is B, this is C, this is D. I'll retain all. See here also, all the vertices are connected, but it is not forming a cycle. Here one edge is missing. This is one spanning tree. This is one spanning tree. In the same way, you can write some more spanning trees. Okay, this is called as a spanning tree. A spanning tree is a tree in which all the nodes are connected without forming any circuit. Okay, and this, what do you mean by the cost of the graph? Here on these edges, if I mention any number like this, 10, 20, 30, 40. If I mention the number on these edges, then this will be called as the cost of that graph. From A to B, cost is 10, B to D, cost is 20, from C to D, cost is 30, and A to C, cost is 40. Okay, now I'll come for the main thing. What do you mean by minimum cost spanning tree? Say, for example, I have just told you here, this is the main graph, and here these are the spanning trees. Some more possible spanning trees here are what? A, B, C, D. This is one possible spanning tree, and then one more, A, B, C, D. These are the four possible spanning trees we can write from this main tree. Now, what is the cost? From A to B, it is 10. Here, A to B edge is not there. From B to D, it is 20. From C to D, it is 30. This is 40. At the same time, here, A to B, it is 10. A to C, it is 40. C to D, it is 30. Here, it is 10, 20 and 30. A to B, again 10, this is 20 and this is 40. This is the spanning tree with cost. You have to find out minimum cost spanning tree. First, what do you mean by minimum cost spanning tree? A minimum cost spanning tree is a spanning tree whose cost is minimum. Means if you sum up all the cost, then it should be minimum. See here, 40 plus 30, 30 plus 20 is 70, 70 plus 20 is 90, 90 plus 10 is 100. The total cost of this main graph is 100. Let me come for this one. What is the cost, total cost of this 40 plus 30 is 70. 70 plus 20 is equals to 90. Now this is 40 plus 30, 70, 70 plus 10, it is 80. What about this one? 10 plus 20, 30, 30 plus 30, this is equals to 60. Then 40 plus 10, 50, 50 plus 20, it is 70. These are the 4 spanning trees I have written. Among these 4 spanning trees, which spanning tree is giving minimum cost? This spanning tree is giving minimum cost. So this spanning tree is called as your minimum cost spanning tree. The spanning tree which gives the minimum cost, that is called as the minimum cost spanning tree. Why we use this minimum cost spanning tree? See, I'll just tell you the one live example for this one. For example, I'll just take the Samram College itself. For Samram College, we can come from many different ways. There are many different roads to come to Samram College. See, for example, from Yelhanka we can come, from MS Palya we can come. Okay, like that from many places you can come, but you have to just find out which is the minimum path to come to your college. That is called as your minimum cost spanning tree. In order to find out the minimum path in the graph, we use this minimum cost spanning trees. Okay, yes, see here in this minimum cost spanning tree, we have 2 different minimum cost spanning trees. That is very important. One is 2 minimum cost spanning tree we are going to study. First one is Prim's algorithm, and the second one is Kruskal's algorithm. Both these algorithms are written in order to find out the minimum cost spanning tree. These are very important, Prim's algorithm and Kruskal's algorithm. Now let us discuss first the Prim's algorithm. What do you mean by this Prim's algorithm? Okay, this Prim's algorithm will construct a minimum spanning tree through a sequence of subtrees. Means here first one graph will be given. From that graph, by using this Prim's algorithm, you have to find out the minimum spanning tree. Okay, here how you are going to do that? When first you have to select, see, I have a graph A, B, C and then D. Okay, this is my main graph what I have. By using Prim's algorithm, you have to find out the minimum spanning tree. To do that, what I have to do is, first I have to select any one vertex as the arbitrary vertex, as we have done in the last problem. So I'll just select A as a arbitrary vertex over here. So from A to B, from A, for how many vertices you have a edge? From A to B it is 10, A to D it is 40. Among these two, which is minimum? 10 is minimum. So I'll just take this one, A to B. First I'll go with A to B. This is 10. Now I have a node B here. From B also you have to do the same thing. From B, how many edges are there? 2 edges. From B to A, 10. B to C, it is 20. B to A, it is already done. So only one left out. So I'll just take this only. To C. Next, from C again, C to B, it is 20. C to D, it is 30. C to B, it is already done. So C to D is left out. I'll just take C to D. From D, if you take from D to A, cycle will form. This will not become the spanning tree. From D to C, it is already done 30. So this is my spanning tree, minimum cost spanning tree, what I have got from the Prim's algorithm. See, here also we have got the same thing. Here from Prim's algorithm also I have got the same thing. This is how you have to do the Prim's algorithm. See how? First you have to select the arbitrary vertex, then you have to just see the edges, outgoing edges from arbitrary vertex A, and which is minimum among that you have to select. Then next node. Like that you have to just mark all the nodes as visited. If all the nodes are mark visited, then only you'll just get the minimum spanning tree. Now we'll go for the algorithm of your Prim's algorithm. Means for your Prim's algorithm, I'll just give you the algorithm. See, Prim's algorithm for constructing a minimum spanning tree. This algorithm is to construct a minimum spanning tree. What is the input? A weighted connected graph. Always the graph is the input. Means in your system, if you are dealing with Prim's algorithm or Kruskal's algorithm, all those things, if you have any of the graphs, then first you have to convert this graph into a adjacency matrix, and then that you have to, that adjacency matrix has to be given as input in your system. Okay, now output ET, that is edge, the set of edges composing a minimum spanning tree of G. Okay, now Vt is equals to V naught. V is the number of vertices, E is the number of edges. First you have to select first vertex as the arbitrary vertex, so I am just taking it as V naught. Okay, ET, edges will not be present in the beginning, so I will initialize it as null. For I is equals to 1 to V minus 1. Okay, V minus 1, why I am taking it as 1 to V minus 1? Already one vertex I have taken it as arbitrary vertex. We have left out with only V minus 1 vertices. So I will take it as I is equals to 1 to V minus 1. Find a minimum weight edge. I have just told you from the arbitrary vertex you have to find the minimum weight edge. You have to first write all the edges with the weight, then among those edges one minimum weight edge you have to select among all the edges V comma U, such that V is in Vt. Vt means it is the vertices visited and U is in V minus Vt. V minus Vt means we'll take it as vertices which are unvisited. Okay, now if that is the case, then that vertex you have to make it as visited, and then that edge you have to draw from one vertex to another vertex. If it repeats for V number of times, then at last you have to return the edges which you have got. Okay, now I'll go for the problem, then I'll understand how you have to just do this one. Okay, see, this is the graph I have taken. See, obtain minimum spanning tree for the following graph using Prim's algorithm. This is the graph I have taken. Here is the table what we have to take for Prim's algorithm. This is visited vertex. If you visit, then you have to mark it as visited. Unvisited vertices, that is V minus Vt, then you have to find the edge from every vertex in unvisited set. Then select a set edge ET. Okay, now first I'll take the edge 1, sorry, vertex 1. This is vertex 1, I'll mark as visited. Okay, what are all the unvisited vertices over here? See here, from 1 to 6 we have vertices. Here 1, if I mark it as visited, then 2, 3, 4, 5 and 6 are unvisited vertices. Now find the edge from every vertex in unvisited set to the visited set and find the minimum. From 1 to 2, 3, 4, 5, 6 you have to find out all the vertices. See, from 1 I'll just find out from 1 to 2. From 1 to 2, what is the cost? It is 25. From 1 to 2, cost is 25. This is 1. This is the arbitrary vertex. From 1 to 2, this is 2, 25. Okay. Next, from 1 to 3. From 1 to 3, what is the cost? It is 15. For all the vertices you have to take. From 1 to 4, there is no edge, so it is infinity. If no edge means you have to take it as infinity. From 1 to 5, again it is infinity. There is no direct edge from 1 to 5. From 1 to 6, there is no direct edge, again infinity. See here, from 1 to 2, 3, 4, 5 and 6 I have taken. From 1 to 2 it is 25, 1 to 3 it is 15, 1 to 4, 5 and 6 there is no direct edge, so I have taken it as infinity. Among these, all these what is this? Which edge is having minimum weight? See, it is 25. All these are infinity. This is 15. So this is having minimum weight. So here I'll just write from 1 to 3, it is 15. Okay, from 1 to 3, 15. Now in this, which vertex is visited now? The vertex 3 is also visited. So here I'll mark 1, 3 as visited. Unvisited vertices other than 1 and 3, all the vertices are unvisited. Now the same thing you have to repeat from 3 to 2, 4, 5 and 6 you have to do, because to 1 it is already done. Is it not? So from 3 to 2. 3 to 2. Is there any direct edge? No. It is 2, infinity. Okay. From 3 to 4. Is there any direct edge? No. Again, it is infinity. From 3 to 5. Is there any direct edge? Yes. 3 to 5. It is 20. From 3 to 6. Is there any direct edge? No. It is 6, infinity. See, all these are infinity. Only one with minimum edges 3 to 5. So already we have got 1 to 3, it is 15. Now I have got 3 to 5, it is 20. Okay. Now here the edge 5 is also visited. Whichever comes in this edge set, then those vertices you have to mark as visited. 1, 3 and 5. 1, 3 and 5. Other than 1, 3 and 5, 2, 4 and 6 are unvisited. Now from which one you have to take? From 5 you have to take. From 5 to 2, 4 and 6. See, from 5 to 2, is there any edge? Yes. From 5 to 2, is there any direct edge? Yes. That is 40. Sorry, it is 2, 40. From 5 to 4, yes, from 5 to 4 it is 10. 4, 10. From 5 to 6, yes, again you have. That is 6, 45. See, here from 5 to 2, 4 and 6, for all the things you have edges. But which is minimum? 5 to 4 it is 10. This one you have to consider. So here 1 to 3, it is 15. 3 to 5, it is 20. 5 to 4, it is 10. This one I'll take. Now which is visited again here? 4 is visited. So 1, 3, 5, 4. These are visited. Then 2 and 6 are unvisited. Now from which? From 4 I have to take to 2 and 6. From 4 to 2. Is there any edge? Yes. That is 2, 30. From 4 to 6. Yes. Again it is 6, 50. So which is minimum among these two? 2, 30. From 4 to 2, 30 is minimum. So I'll write 1 to 3, it is 15. 3 to 5, it is 20. 5 to 4, it is 10. Then 4 to 2, it is 30. Yes. Next. 1, 3, 5, 4 and 2 are visited. Only 6 is unvisited now. Now from 2 you have to take, only 6 is pending. From 2 to 6, is there any edge? Yes. That is 6, 35. Is it not? Yes. 6, 35 you have. So I'll just take this one. It is 15. 3 to 5, it is 20. 5 to 4, it is 10. 4 to 2, it is 30. 2 to 6, it is 35. This is your minimum spanning tree. Okay, see here. Next, all the vertices are visited. 1, 2, 3, 4, 5 and 6. Now you have to find out the total cost. Total cost. What is the total cost? 15 plus 20 plus 10 plus 35. What is the cost? 30, 60, 95, 110. 110 is the minimum cost you will get, and this is the minimum spanning tree you will get for this given graph. Okay, this is very important. First you have to take the first vertex.